Each of us is a tiny being, permitted to ride on the outermost skin of one of the smaller planets for a few dozen trips around the local star. Wonderful perspective provided by the great Carl Sagan. This presentation includes video clips to help you try and conceptualize the scale of our universe.
The universe. How big is it? Does it have a center? Does it have an edge? Is it getting bigger? And if so, why? Well, we know that there are two different meanings for universe. First, the observable universe is everything that we've been able to see or observe thus far. And second, the universe, or the whole universe, means everything that exists or has existed or will exist. More specifically, the observable universe is the region of space visible to us from Earth. And since the universe is only about 13.8 billion years old, and light takes time to travel through space, then regardless of what direction we look, we see light that's been traveling at most 13.8 billion years. So it's logical to think that the observable universe must then be 2 times 13.77 equals 27.5 billion light years across. But it's not. That's because over time, space has been expanding, so the distant objects that gave off that light 13.8 billion years ago have since moved even farther away from us. Today, those distant objects are a bit more than 46 billion light years away. Multiply times 2 and you get 93 billion light years, the diameter of the observable universe. To give you a sense of scale, the size of the Earth within the observable universe is roughly equivalent to the size of a virus within the solar system. Although that doesn't help much because we can't really appreciate the incomprehensible smallness of a virus nor the bewildering bigness of our solar system either. So let's just say that the observable universe is stupendously big. But the whole universe, as far as we can tell, is a lot bigger. Space is most likely infinite, or at least it doesn't have an edge, though the difference between those is another story unto itself. Now, what about the center of the universe? Well, the observable universe has a center. Us. We're at the center of the observable universe because the observable universe is just the region of space visible from Earth. And kind of like how the view from a very tall tower is a circle centered on the tower, the piece of space we can see from here is naturally centered here. In fact, if you want to be more precise, each one of us is the center of our own observable universe. But that doesn't mean we're at the center of the whole universe, just like the tower isn't the center of the world. It's the center of the piece of the world that it can see, up to the horizon. But just because you can't see beyond the horizon doesn't mean there's nothing there. And so it is with the observable universe. Looking up at the sky, we see light that's at most 13.8 billion years old and coming from stuff that's now 46 billion light years away. Anything farther is beyond the horizon. But each second, we see new, even older light coming from slightly farther away, 3 light seconds farther to be precise. And so our view of the cosmos is literally getting bigger all the time. All we have to do is wait and watch as the universe ages and light from more distant places has the time to get to us. So here we are, sitting at the center of our observable piece of the whole universe. How big is the universe? Well, the observable universe is currently 93 billion light years across. The whole universe is probably infinite. Does the universe have an edge? The observable universe does. It's 46 billion light years away in any direction. And the whole universe has a temporal edge, or what we call a beginning, but almost certainly not a spatial one. Does the universe have a center? Again, the observable universe does. You. The universe as a whole? Almost certainly not. And is the universe getting bigger? Yes, space is expanding, which makes both the observable universe and the whole universe bigger. Plus, over time, we see older and older light coming from farther and farther away, so our observable universe gets bigger that way too. And that, in a nutshell, is our view from the tower. You are the center of the universe, and so am I, and so is everyone else, and so is no one.
Good to know we're all centers of the universe. The next clip, it's a little bit longer clip. It's a classic. It's the powers of 10, and each time they pan away, they are zooming away at another power of 10. They'll start in Chicago and pan away. Enjoy the classic. I know you'll want the soundtrack. The only thing that's been removed are the beeps to advance the next slide forward for you. Enjoy this clip that was shown in all science classes the very first day, no matter what grade you were in, whether you were in biology, physics, chemistry, astronomy, geology, you knew you were going to watch the powers of 10 on day 1.
The picnic near the lakeside in Chicago is the start of a lazy afternoon, early one October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now every 10 seconds we will look from 10 times farther away, and our field of view will be 10 times wider. This square is 10 meters wide, and in 10 seconds the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Power boats lie at their docks. The colorful bleachers are Soldiers Field. This square is 1 kilometer wide, 1,000 meters. The distance a racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters. The distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1,000,000 meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey. The Earth diminishes into the distance, but those background stars are so much farther away that they do not yet appear to move. A line extends at the true speed of light. In 1 second, it half crosses the tilted orbit of the moon. Now we mark a small part of the path in which the Earth moves about the Sun. Now the orbital paths of the neighbor planets, Venus and Mars, then Mercury. Entering our field of view is the glowing center of our solar system, the Sun, followed by the massive outer planets, swinging wide in their big orbits. That odd orbit belongs to Pluto. A fringe of a myriad comets too faint to see completes the solar system. Ten to the 14th. As the solar system shrinks to one bright point in the distance, our sun is plainly now only one among the stars. Looking back from here, we note 4 southern constellations, still much as they appear from the far side of the Earth. This square is 10 to the 16th meters, 1 light year, not yet out to the next star. Our last 10-second step took us 10 light years further. The next will be 100. Our perspective changes so much in each step now that even the background stars will appear to converge. At last we pass the bright star Arcturus and some stars of the Dipper. Normal but quite unfamiliar stars and clouds of gas surround us as we traverse the Milky Way galaxy. Giant steps carry us into the outskirts of the galaxy. And as we pull away, we begin to see the great flat spiral facing us. The time and path we chose to leave Chicago has brought us out of the galaxy along a course nearly perpendicular to its disk. The 2 little satellite galaxies of our own are the clouds of Magellan, 10 to the 22nd power, 1,000,000 light years. Groups of galaxies bring a new level of structure to the scene. Glowing points are no longer single stars, but whole galaxies of stars seen as one. We pass the big Virgo cluster of galaxies among many others, 100 million light years out. As we approach the limit of our vision, we pause to start back home. This lonely scene, the galaxies like dust, is what most of space looks like. This emptiness is normal. The richness of our own neighborhood is the exception. The trip back to the picnic on the lakefront will be a sped-up version, reducing the distance to the Earth's surface by 1 power of 10
Hold on to your
every
britches.
2 seconds. In each 2 seconds, we will appear to cover 90% of the remaining distance back to Earth. Notice the alternation between great activity and relative inactivity, a rhythm that will continue all the way into our next goal, a proton in the nucleus of a carbon atom beneath the skin on the hand of the sleeping man at the picnic. 10 to the 9th meters, 10 to the 8th, 7, 6, 5, 4, 3, 2, 1. We are back at our starting point. We slow up at 1 meter, 10 to the 0 power. Now we reduce the distance to our final destination by 90% every 10 seconds, each step much smaller than the one before. At 10 to the minus 2, 1/100th of a meter, 1 centimeter, we approach the surface of the hand.
Oh boy, this is why I didn't go into biology.
In a few seconds, we'll be entering the skin, crossing layer after layer from the outermost dead cells into a tiny blood vessel within. Skin layers vanish in turn. An outer layer of cells, felty collagen. The capillary, containing red blood cells and a roughly lymphocyte. We enter the white cell. Among its vital organelles, the porous wall of the cell nucleus appears. The nucleus within holds the heredity of the man in the coiled coils of DNA. As we close in, we come to the double helix itself, a molecule like a long twisted ladder whose rungs of paired bases spell out twice, in an alphabet of 4 letters, the words of the powerful genetic message. At the atomic scale, the interplay of form and motion becomes more visible. We focus on one commonplace group of 3 hydrogen atoms bonded by electrical forces to a carbon atom. 4 electrons make up the outer shell of the carbon itself. They appear in quantum motion as a swarm of shimmering points. At 10 to the minus 10 meters, 1 angstrom, we find ourselves right among those outer electrons. Now we come upon the 2 inner electrons held in a tighter swarm. As we draw toward the atom's attracting center, we enter upon a vast inner space. At last, the carbon nucleus. So massive and so small. This carbon nucleus is made up of 6 protons and 6 neutrons. We are in the domain of universal modules. There are protons and neutrons in every nucleus, electrons in every atom, atoms bonded into every molecule out to the farthest galaxy. As a single proton fills our scene, we reach the edge of present understanding. Are these some quarks at intense interaction? Our journey has taken us through 40 powers of 10. If now the field is 1 unit, then when we saw many clusters of galaxies together, it was 10 to the 40th, or 1 and 40 zeros.
The following clip will show you just what a popular classic The Powers of 10 was and how ingrained it was in the minds of creators of this now classic. And maybe for a different generation, feel free to sing along, or at least in 2 in the morning, your eyes will pop open as you sing along to this. Note, this was pre-2006.
Everybody lives on a street, in a city or a village or a town for what it's worth. And they're all inside a country which is part of a continent that sits upon a planet known as Earth. And the Earth is a ball full of oceans and some mountains, which is out there spinning silently in space. And living on that Earth are the plants and the animals and also the entire human race. It's a great big universe and we're all really puny. We're just tiny little specks about the size of Mickey Rooney. It's big and black and inky and we are small and dinky. It's a big universe and we're not. And we're part of a vast interplanetary system stretching 700 billion miles long. With 9 planets and a sun, we think the Earth's the only one that has life on it, although we could be wrong. Across the interstellar voids are a billion asteroids, including meteors and Halley's Comet too. And there's over 50 moons floating out there like balloons in a panoramic trillion-mile view. And still it's all a speck amid 100 billion stars in a galaxy we call the Milky Way. It's 60,000 trillion miles from one end to the other, and still that's just a fraction of the way. 'Cause there's 100 billion galaxies that stretch across the sky, filled with constellations, planets, moons, and stars. And still the universe extends to a place that never ends, which is maybe just inside a little jar. It's a great big universe, and we're all really puny. We're just tiny little specks about the size of Mickey Rooney, though we don't know how we got here. Really important part here, it's a big universe.
And you're welcome for those little ditties to poison your mind with.